You ever see one of those amazing data visualizations and just wonder, how did they do that? Well, before you get to any of the cool charts or big flashy insights, there's this really crucial first step. It's called data wrangling, and it's all about taming the absolute chaos of raw data.
And this quote from Hadley Wickham just hits the nail on the head, doesn't it? See, in the real world, data is never neat and tidy. It's inconsistent, it's disorganized, it's just plain messy in a million different ways. And our job? It's to fix that mess.
So what is this transformation process? The best way I can describe it is it's like prepping ingredients before you start to cook. Data wrangling is all that essential prep work, the chopping, the cleaning, the organizing that makes the final dish, your analysis, even possible.
And this is the goal. We want to move from the chaos on the left to that clean, logical structure on the right. We call it tidy data. And in a tidy world, it's simple. Every column is a variable, and every single row is one observation. That structure right there, that's the gold standard we're aiming for.
So how do we get there? We're going to use this amazing set of tools called the Tidyverse. But here's the thing. The Tidyverse is so much more than just a bunch of software. It's a whole philosophy. It's a consistent, logical way of thinking and working with data that makes the whole process feel, well, surprisingly intuitive.
And the secret ingredient that makes the Tidyverse so powerful? It's this thing, the pipe operator. I know, it looks a little weird, but what it does is beautifully simple. It takes the output from one step and just pipes it right into the next one. This means we can write code that flows together and reads just like a sentence, from left to right. All right, so how does this all work in practice? Well, the Tidyverse gives us this set of simple functions that basically act like verbs. These are the actions we're going to take, step by step, to clean up our data. We're going to focus on 5 of the big ones. Filter for picking the rows we want, select for picking columns, mutate for creating new columns, and then this powerhouse duo, group by and summarize, which help us get those big picture insights. First up is filter, and it does exactly what it sounds like. Think of it like a sieve. It sifts through all your data and only keeps the rows that match a specific condition you give it. So maybe you only want to see sales from California, or just the customers who signed up in the last week. Filter is how you do that. And just look how readable this is. We're taking our flights data set, we're piping it into the filter command, and we're just saying, hey, only keep the rows where the month equals 1. It's that simple. We've just isolated every single flight from January. Okay, next up we have select. So if filter is for rows, select is its partner for columns. This is our tool for just zeroing in on the variables we actually need. It's perfect for cutting through the noise, especially when you've got a data set with like hundreds of columns. So right here, we're taking that same flight's data, and we're telling it, you know what? I only care about these 4 columns, the year, month, day, and carrier. And instantly, our view is so much cleaner and focused on what really matters for the question we're trying to answer. Now, this is where things get really cool. Mutate is incredibly powerful because it lets us create totally new columns from the ones we already have. This isn't just cleaning anymore. This is what we call feature engineering. We can actually calculate new pieces of information and add them right back into our dataset. So for example, here we can take the arrival delay and the departure delay, add them together, and then mutate our data to create a brand new column called total_delay. With just one line of code, we're literally adding new knowledge to our data. And now for the dynamic duo, group by and summarize. These two are an absolute dream team. They work together to take huge amounts of data, thousands of rows, and collapse them into these really concise, meaningful summaries. This is how you find things like the average or the sum or the total count for different categories. It's a 2-step process. First, we group by the carrier, which is kind of like sorting all our flights into separate buckets, one for each airline. Then, for each of those buckets, we summarize by calculating the average departure delay. And the result? A nice, simple table showing the average delay for every single airline. Okay, so beyond just cleaning and calculating, sometimes you have to completely reshape your data to really see the story it's trying to tell. And that often means changing its structure from what we call a long format to a wide one. So take a look at this. This is called long data. Each row is a single, neat observation, one airline in 1 month with one average delay. It's perfectly tidy and super useful for a lot of things, but it's not great for comparing months side by side. But check this out. With one command, pivot wider, we can completely transform it. We're telling our, hey, take the names from the month column and use them to create a bunch of new columns. And voila, here's the result. This wide format makes it so easy to just scan across a single row and compare an airline's delay across all the different months. It's the exact same data, just a totally different perspective that tells a different story. Of course, data rarely lives in just one file. A lot of the time, we have to combine different data sets, and this can be tricky, which is where this funny but very, very true quote comes from. Getting your merges right is an absolutely critical skill. And using a function like left join, we can do this really cleanly. So here, we're taking our flights data, which just has a 2-letter code for each airline, and we're joining it with another table that has the full airline name. That by equals carrier part, that just tells the function how to match the two tables up. Simple.
Okay, so after all that work, the filtering, selecting, mutating, reshaping, why does it all matter? Let's talk about the big payoff.
The payoff is huge, and it comes in 3 key areas. First, your data quality goes way up, which means you can actually trust your analysis. Second, you become way more efficient, so you can spend your precious time finding insights, not fixing errors. And ultimately, it all leads to better, smarter decision-making. High-quality data leads to stronger conclusions. It's really that simple.
You know, at the end of the day, data wrangling isn't just some boring technical chore. It's the art of making data speak clearly. It's about cleaning up all the static and noise so you can finally hear the story that's been waiting inside all along. So the only question left is your data tidy enough for you to hear it?